All right, hi everybody, welcome back. Today we're going to be looking at parametric equations. So on the screen here you have the definition for what it means to be a parametric equation. And we're going to be looking at these parametric equations and how we're going to be working with them, not only algebraically, trigonometrically, or geometrically, but we're also going to be working with them using calculus. All right, now this says that if we have two x and y functions here, that those functions are going to be made up of some parameter that we'll call t. All right, and this is typically given over some interval. We'll call that interval I, that contains those t values. And what we're going to do is we're going to take every single ordered pair that satisfies this specific function outputs, and those are going to be the ordered pairs that go in our Cartesian coordinate system. But if you notice here, the x coordinate is now some function that will change independently, and that's it's going to change dependent on the t value. And the same thing is going to happen for g, or in this case for the y coordinate. It's going to be able to change freely depending on some variable t. All right, now again, these equations will make a parametric curve, and that parametric curve will be made by these parametric equations that we work with. All right, now on here on screen you see a coordinate system on here that I have for x and y. And what I want to do is I want to kind of bridge the gap that you kind of already know what parametric equations are. We just haven't really defined it that way. All right, so I'm going to give you an example where we define them and where we're going to go ahead and we're going to classify them slightly different, or we're going to rewrite them slightly different. That way we can still work with those equations. All right, so I want you to think back from trig. All right, so you're going to recall from trigonometry. Here goes. Let me know if you've seen this before. And I say, let me know if you've seen this before, like if everybody's in here while I'm doing this video, right? So naturally I can hear a lot of people saying, yeah, we've seen that before. X is cosine, y is sine theta, awesome. Well, what does this represent if we both have an R value of 1? Well, naturally that represents what we know to be as the unit circle. This is a parametric equation, or these are parametric equations, and this here, this unit circle, is the parametric curve. Now, why are these parametric equations if they don't have the variable t? Well, the variable t is just some random variable that we choose. Naturally, we choose t because x, y, and z are kind of already taken. F, g, h, they kind of represent functions, so on and so forth. So we naturally just use t. So if I were to think about this slightly different, or if I were to rewrite it slightly different, check this out. Would this still represent the same thing, not even, but when I do this? Sure, because once again, theta was initially bounded, if you remember from trig, for that unit circle. Oh wow, what is going on there? My apologies, everybody. Technical difficulties, we'll get through it. There we go. So what was happening here? Well, we were using theta as our parameter. Using theta as a parameter, we were able to then build this unit circle. And again, we didn't call the unit circle a parametric equation at the time, unless your professor did, but most people don't. All right, they just say we're going to look at this and this is going to be the input of some angle. Well, naturally, it still satisfies the parametric equation feel. The parameter is the variable t, and the parameter bounds are from 0 to 2 pi. And as we traverse from 0 to 2 pi, in other words, from smaller to larger on the parameter values, what we do is we start traversing around this unit circle in a counterclockwise direction. And typically with parametric curves, we want to put an orientation on these curves, meaning we want to know what way they are traversing. All right. So this is what we're working with in this particular section, except they're going to get a little bit more, let's say, awesome. All right. So they're going to get a little bit more fun. Now, let's look at one example here. That way we can start illustrating what kind of curves we actually get to see. So here goes the first curve. We want to sketch the curve defined by the parametric equation x is equal to t squared, y is equal to t plus 1, and t, let's say t is going to be unbounded. Notice I'm still putting this interval around t. This is just to satisfy my option that this value for these parametric equations will always be increasing or decreasing depending on what t values we're going to be looking at. All right. So in order to do this, what we're going to do really quickly is we're going to have to start picking some t values. And when we choose some of these t values, we're going to have to plug them into the x and y coordinate, and then we're going to have to observe what are those outputs in the Cartesian coordinate system. All right, so let's generate a quick table really quick. That way we can see how we're going to work with this. All right, so here's my table. I have my t coordinates, my parameter values for t. Then I'm going to plug those into the x, the y, and then I'll see what kind of ordered pair I get. All right, so naturally we want to go with a few points just to get a feel for what this curve might be doing. All right, so I'm going to go for my t values just by looking at these guys here, t squared and then t plus 1. I kind of want to go with -2, -1, 0, 1, and 2. All right, so let's sub this in. Let's take t is equal to -2, plug it into the x value, and we should get 4. -2 into my t value for my y's, and we should get -1. All right, there we are, -1, perfect. The next one we're going to substitute in -1, so -1 squared, that's just going to be 1. -1 plus 1, that's going to be 0. The next one's going to be 0 squared. The next one's going to be 0 plus 1. The next one's going to be 1. 1 plus 1, that's going to be 2. 2 squared, that's going to be 4. And then 2 plus 1, that's going to be 3. So these are all of the ordered pairs that we're able to extract at this point in time. And this is what they look like. Now, we're going to go ahead and we're going to put all of these ordered pairs on an x and y coordinate system. That way we can see what is the curve that this parametric equations is defining. All right, so let's get a good grid going. All right, so here's my grid. All right, now that I have my grid, I'm going to go ahead and I'm going to start making these substitutions in. All right, now my apologies. I do see here that we're going to go down into the negatives. So I'm going to make sure that I go down into the negatives as well. All right, so that was, let's see, 3, 4, 1, 2, 3, 4. There we are. So that's going to be -1 there. Perfect. All right, so let's go 4, and then that was -1 down here. That's the first point. The next one's going to be 1, 0. The next one's going to be 0, 1. The next one's going to be 1, 2. So at 1, then we're over here at 2. Perfect. And then the next one's going to be, if we're at 4, then we must be up at 3. There we are. So what this curve now looks like, if we start from t is -2 and we start increasing, Well, that actually gets us to move in this direction like this. So that's exactly what I'm going to do. I'm going to start sketching this curve to move in that direction, just like this. Bingo. And the curve is increasing in this direction. So naturally, I'm not going to put an arrow going in this direction because that would be false. I'm actually increasing in this direction just like this. And we keep moving in that direction. So again, this is the parametric curve that these parametric equations are generating. Now, if we want to get a little bit more accurate here, this first point that we found, this point of 4, -1, this was a t-value of -2. The next ordered pair that we found was a t-value of -1, then it was a t-value of 0, then t-value of 1, then t-value of 2. Notice I explicitly give these t-values, that way we can see what way it's increasing, not only with the arrows, with the directional arrows, but we can also say, hey, t is increasing in this direction, therefore just follow the arrows. All right. Now that we have this down and we know how to generate these curves, what I want to do now is I want to actually go into a separate question, and I want to say that we can identify this curve without actually plotting it. All right, so can we identify the curve without graphing the parametric equations? So that's going to be one of our big thoughts, is can we do this, and can we identify it without graphing the parametric equations, without going through the whole table process, right? Now, the answer to that is going to be yes, yes we can. Now, what way are we going to be able to do this, or how are we going to be able to do this? Whoa. Whoa, whoa, whoa. Sorry about that, guys. There we go. All right, so the other equation was y is equal to t plus 1. There we are. All right, so what I'm going to do at this point in time is notice that both equations depend on t. So what I can do is I can solve for t on one equation and then make that substitution into the other equation. All right, and that's what I'm going to do here, is I'm going to take this equation and I'm going to solve for t. Once I solve for t, I'm going to make that substitution. All right, I'm going to say substitute. And once we substitute in, what we'll get is that x is equal to y minus 1 squared. Now, this equation right in here, this is the equation of a parabola that opens sideways, and this actually opens to the right, and it's shifted up by 1. Oh, let's wait really quick. My computer's not done processing and it might do some weird stuff again. Shifted, oh, there, see, told you, there it goes. And shifted up, wowzers. My apologies, everybody. These technical difficulties keep on coming in. There we go, perfect. All right, so shifted up 1 unit. There we are. So typically, some of these curves that we want to identify, or some of these curves that we want to work with, are curves that we've kind of seen before. And the trick is not to eliminate the parameter, which is what we did here, but instead to try to attempt to graph it. That way we can see what these parametric equations are doing. All right, so perfect. That looks great. Now let's see if we can generate a different type of example. All right, so here goes this example. Sketch. Wow. No, that is not what I want. All right, so here we go. Here we go, sketch. And identify the path traced by the parametric equations x is going to be equal to t plus 1 over t, y is going to be equal to t minus 1 over t, and we're going to have that t must be greater than 0. Awesome. So now we're going to try to see how all of this is going to start working out for us. All right. So again, we want to make sure that we want to sketch this first. After we sketch it, then we're going to go ahead and we're going to identify what is that path being traced. All right. If we can eliminate the parameter at that time, then we'll go ahead and do so. All right. But for now, at this time, let's go ahead and let's make a table. That way we can go ahead and sketch this specific equation. All right, so here's our table. So we have our t's, we have our x's, we have our y's, and we also have our coordinates. So I'm going to start choosing some random t values, and I want to see what is happening there. All right. Now notice here, t is greater than 0. So when I go with t is greater than 0, I just must choose any positive t value that we can come across. All right. So naturally, what I probably want to do is I want to probably start choosing small t values that are going to get me close to 0 without actually going over into the negative values. All right. So some of those values might look like 0.1. Let's go with 0.2. We could also go with 0. Let's say 4. We can also go with 1. 2, and let's go with 5 as well. Let's see what we get. All right. So here we go. We're going to take 0.1. So we're going to take We're going to take 0.1 and we're going to plug it into the function that we're given here. All right. So naturally, we should get for the x coordinate 10.1. All right. Nice. Now for the y coordinate, if we sub in that value, you can go through the calculations there, but we should get somewhere along the lines of 0.99, negative 9.9, which means my ordered pair should be 10.1, comma, negative 9.9. All right, doing the second one, 0.2. If we sub in 0.2 in for our t values, naturally we're going to get 5.2, and then we're also going to get negative 4.8, which means we get 5.2, comma, negative 4.8. All right, looking good so far. Substitute in substitute in 0.4. So 0.4 right in here, do the algebra work, and you will get 2.9, and then we will get negative 2.1. All right, so my ordered pair is 2.9, comma, negative 2.1. All right, I want you to keep doing the rest. All right, so take some time. You can put pause on the video and fill in the rest. All right, so here are the rest of the filled in values. All right, when t is equal to 1, t is equal to 2, and t is equal to 5. Perfect. So look at all of your ordered pairs here. These ordered pairs, 10.1 and negative 9.9, these ordered pairs, at least the first three, exist in quadrant 4, and then these last three pairs exist in quadrant 1. So when I draw my grid here, I only want points in quadrant 1 or in quadrant 4, so that's how I'm going to make my grid. And I'm going to adjust my scale while I'm at it to make sure that I can meet these requirements to have my x values go up to 10 and my y values go up to, let's say, negative 10. All right, so I'm going to put pause, I'm going to make this grid, and I'll come back in a little bit. All right, so here's my grid. So I'm going to go through and I'm going to start plotting these points. All right, the first one's going to be at 10.1 comma negative 9.9. So I'm going to go over to roughly where about 10 will be. So it's going to be 9, 10, 11, 12, so somewhere around in here. All right, down to negative 9.9. So that'll be, let's say, somewhere down here. All right, so that's my first pair where t was equal to 0.1. Now my next one's going to be 5.2. So I'm going to go over to about where 5.2 would be, so somewhere around in here. And I'm going to go down to negative 4.8. So negative 4.8. Probably somewhere around here, and that's going to be t is equal to 0.2. Nice. Next ordered pair, 2.9, so 2.9 down to negative 2.1, somewhere here. All right, that was t is equal to 0.4, looking good. All right, the next one's going to be at 2, 0. All right, that's going to be perfect, so that's going to be somewhere here, 2, 0. That was t is equal to 1. And then after that, I'm going to go to t is equal to 2, and that was at 2.5. So 2.5, getting closer to 3, and then up at 1.5. So it's going to be somewhere here. Nice. And then the next one's going to be at 5.2. So at 5.2, somewhere here. And then up at 4.8. Looking like it's somewhere here. So that was t is equal to 5, and this one here was t is equal to 2. Now, what it's looking like here is it's looking like it's doing this. And some of you might say, hey, that kind of looks like a parabola. And at first glance, it might look like a parabola, but it's not a parabola. All right, so this question said sketch and identify the path traced. So naturally we might think it's a parabola, but it's actually not a parabola. All right, these values are not growing in a square fashion. All right, kind of like a parabola does. They are growing in some kind of square fashion, but we got to find it. All right, so what I want to do at this point in time is I want to try to eliminate that parameter. All right, so let's see if we can try to eliminate that parameter some way, somehow. See if we can get this. All right, so let's see. Now there might be more than one way to do this, but again, it's going to be up to you experimenting through this whole process. So let's go ahead and let's eliminate the parameter. This means get everything into x and y coordinate form. All right, so if I'm going to eliminate the parameter, let's see, I have some x and some y. Now, I can't exactly go through and solve for t here because t is actually going to be a quadratic, and if I solve for t, it's actually going to get me some x and y, or sorry, some x coordinate, which is going to be positive or negative. So I kind of want to stay away from solving for t here. All right, so here we go. I kind of want to investigate this x minus y, just as a quick analysis. All right, so if I have x minus y, then that means that's going to be t minus 1 over t, and then minus t minus 1 over t. Because again, or sorry, the first one was a plus. So t plus 1 over t, then t 1 over t. All right. Now, the reason I kind of want to investigate this is because it looks like this right here, if I subtract them, some of the t's are going to cancel out. And I actually get, let's see, t's cancel here, and then negative times a negative is a positive. So I actually get 2 over t if I'm not mistaken here, which is real nice, because remember, like I said, the overall goal over here with the initial equations was to eliminate the parameter t, and I said we couldn't exactly do that without getting a quadratic equation. In here we actually were able to eliminate the parameter quite slightly, and we now get 2t, which only has one t value. So I'm going to kind of keep that in my back pocket now. Now, this was just one of the options. Now, I'm still not done, by the way. All right, so the other thing that I want to investigate, now again, I see that the signs are alternating here, so they seem like they have the same binomials, t-value-wise, and that they alternate signs, which means I kind of want to consider what's going to happen when they alternate signs again, when I go ahead and I add the x's and the y's together now. Well, the reason I want to investigate this piece now is because, again, the 1 over t's are going to cancel, and I'm just going to be left with 2t. Now, again, this is nice for us, because what's happening here is that I now have x minus y and x plus y. Both of these are dependent only on one t value. Because of that, I can now try to join forces here. So now I'm going to consider x minus y times x plus y. Well, what was x minus y? That was that 2 over t. What was x plus y? That was that 2t. Right? And I'll make sure I highlight these, that way you guys can go ahead and see them. So that first one was x minus t, and then that was that 2 over t. Nice. And then the other one was, let's do this in kind of a pinkish one. Here we are. This piece was right here, which means that's right here. Awesome. Now, on the left-hand side of this equation here, this is just the difference of squares, which means this is just x squared minus y squared. Look at the right-hand side now. What happens with those t values? Yeah, they go away, which means we're left with this equation. X squared minus y squared is equal to 4. What is that the equation of? Yep. That is a hyperbola. It is a hyperbola. Now, the t values are only greater than 0, which for us, that's going to mean, hey, it's only going to be one side of this hyperbola. All right. Now, let's see if we can now go to, let's say, Geogebra, and see if we can look at this hyperbola and see how that's going to tie into this piece over here. All right. So follow me along. All right. I'm here with my friend Geogebra, and I'm going to go ahead on the input bar here. So I'm just going to have x, whoops, yeah, let's go x squared, there we are. Then I'm going to do a plus, or sorry, that was a minus, my apologies. Whoa. Okay, pause. There we go. Okay, so then cheese and crackers. Give me one quick second. There we go. All right, so it's going to be minus y squared. There we are. And that's going to be equal to 4. So again, we naturally get this hyperbola to occur. All right. Now, this hyperbola kind of looks like the hyperbola that we were actually looking at. All right. But again, we were only looking at one half of it, and that was this right half. So let's see if we can try to generate that one right half with the equations that we were given. All right. So in here, what I'm going to do is I'm going to tell Geogebra that I want this parametric equation. All right, and that's going to be the parametric equation here. So I'm going to do the x coordinate. The x coordinate was t plus 1 divided by t. There we are. And the y coordinate was t minus 1 divided by t. There we are. The parameter variable, well, the variable that we're dealing with is t. Start value, well, Geogebra kind of wants a start value, so I'm not going to go large enough, but I'm going to go to, let's say, negative 20. And the end value, I'll do 20, and then I'm going to hit enter. There we are. Now you're going to say, hey, Mr. Castro, I don't think Geogebra did anything, right? Because I don't see anything. Well, let's go ahead and let's actually change the color here. Oops. I want this one here. Where are you? Here we go. All right, I want to change the color here and making sure, yep, there we are. So I changed the color to red. Now I'm going to hide the hyperbola. All right, let's hide that hyperbola. All right, now my apologies, my parameterization here for my values actually chose -20, and I completely forgot that they needed just to be greater than 0. All right, so let's say that we go over to 0.1, which is where we started, or we can go even smaller than that. All right, so let's go with, let's see where my numbers here go, 0.0, let's say 2. All right, there we are. There it is. Now, I told Geogebra, hey Geogebra, with these given parametric equations, can you graph this? And I'm going to give you the interval, which was your t-values, and sure enough, here it is. Now, again, if I go ahead and display the curve, just like this, there we are, then we actually get to see the equation of that hyperbola. But again, we're not looking for the whole equation of the hyperbola, we're only looking for the half of the hyperbola, which is only the right-hand side, because of the parameters that we were given. All right, so awesome. This is a visual that I typically use for Geogebra, and this is how I typically envision these particular items. All right, so let's go back to class. All right, here we are. So that's going to actually wrap it up for section for this particular section when we're dealing with parametrization of curves. All right. Now, I'm going to also say that parametrization of curves happens so much in upper division courses that after you leave this specific course, after you leave Calculus 2, you will see it again in Calc 3, you will see it again in differential equations, and you will see it again in linear algebra. All right, so it's not something that's going to go away, and preferably you want to master it at this point in time. That way, once you get to those specific courses, it's not so debilitating to try to understand what is taking place. All right, so I hope you all enjoyed this, and I will see you all for the next course.